Hello everyone, good evening. We will wait for a couple of minutes so that the other people can join by the time. So yeah, now we will get started with our session. So in today's session, we will be talking about the segmentation. So basically, just open segmentation of knee anatomy. So before going ahead with actual segmentation, just wanted to discuss about like what is the meaning of the segmentation in the medical imaging field. So whenever we wanted to convert any 2D image data into a 3D virtual model, so in the simple language that we call as a segmentation. So if you have gone through with the medical images, like we earlier in the episode 1, we talked about uh, what is a medical image and how it is being stored, also about the DICOM image and where these medical images are stored. So if you take an example of X-ray or CT image, those basically are the 2D images, which is having the grayscale images. So we will learn about in today's session about the DICOM image and how we can read the information about those images, whether it is in CT, whether it is in MRI, we will be able to get the information. And in today's session, we will be focusing on the CT image segmentation. So we will be covering these 5 points: DICOM image information, segmentation tools, conversion of mass to object, measurement, and export of 3D virtual model, means the object. So uh, we, today's session will be most of the practical session where I will be giving the demonstration converting a 2D image data into a 3D virtual model. So for this session, I will be using my segmenter software, which helped me convert the 2D image information into a 3D virtual model. So I will give you the information of the software, how you can download, how you can access it in the last stage of our webinar. So I'm just switching on to the software now. So this is the segmentation software, which is the My Segmenter software, which help us to convert 2D image data into a 3D virtual model. But initially, when you install the software, you will see in these 4 screens: axial, coronal, sagittal, and 3D scene. We will see once we import this DICOM image into our software. So to import the DICOM image, we need to click on the file menu. In the file menu, you have a couple of options: DICOM import, uh, the volume import, the STL import, open project, anonymize dataset, and save as, and close project. So to get started with the import of the 2D image data, we just need to click on import DICOM data. As my data is present on the desktop, I'm just selecting that. So in today's session, we will be focusing on knee image. So I'm just clicking on import. So you can see the data is imported here. And if I double click here, I will be able to see the image data information. So for one patient from the scan sector, you can receive one image data series or multiple series. So for this particular patient, we are having 4 image data series. So here in the first series, you are able to see the total number of images are 48. In the second, 48, and the third, it is 243. In the fourth, the total number of images 243. You can verify from here. So these are the DICOM images set. But if you wanted to check the DICOM information in detail, so you just need to, as we discussed earlier, like along with the 2D images, we have the data associated with it. So if we click on show metadata, you will be able to see the information for that particular series. So here, if we talk about the patient name, so this first indicate the DICOM tag, and associated with this DICOM tag, the attribute is written. So these are the general tags. If you go with any other information or any other tag, you will be able to get the information. And this is true for all the DICOM images that you are importing. So if you go with this particular DICOM tag, 0010 0010, it will always give you the information of patient. But for our demonstration purpose, this data is being anonymized. So patient name we have erased and it is replaced by the pseudo data. So that is why you will not be able to see the patient name here. Likewise, related to the patient, we can also get the information of patient ID, patient birth, patient sex, slice. These are the information related to the patient you can get. Regarding the technical detail of the scan itself, like the slice thickness of the image. These are the 43 images that we are having. Each is having the slice thickness is 1 mm. So we will be able to see it in detail when we are importing it into the software. So likewise, you can get information of uh, that particular scan in detail here. And if you go search with the DICOM tag information, DICOM tag here, then you will get the, all the DICOM tag information here. Whatever the DICOM tag you wanted to see specific information. So these are the specific DICOM tags. And in couple of series, these particular tags will not be there. If it is the data is there in the DICOM series, then you will be able to see it here. But specific generic tag will always be there. For example, this patient name, patient ID, this slice thickness, all these tags information will be here. So now we have this series that I will be loading into the software, which is having 243 images. Why I'm not going with the fourth one? Because the resolution of the third series is better. So I'm just loading this image into the software. Now, in the beginning, you can see the image has been divided into the 4 different sections. So this is the axial view, this is coronal, and this is sagittal. In layman terms, if you have the engineering background, then this we can consider as a top view, this we can consider as a front view, and this we can consider as a side view. So these all 3 images are linked to each other. So if I hover my mouse to specific this particular part, I will be able to see this particular pixel in the other views as well. Now, as we discussed earlier as well, each pixel is having some countable unit value, and how we can differentiate this information, 2D information, and how we can convert this 2D image information into a 3D model. That is the segmentation process. And to do that process, we'll be needing a couple of tools, which we call as the segmentation tools. We will see detail. Before that, I just wanted to show the pixel information onto the right side of this particular window. If I hover my mouse, I will be able to see each pixel value differently. Now, if you see in this image, the bone part is much more brighter, and For our demo purpose, we will be considering the bone part to be segmented or to be created as a 3D virtual model. So to capture this particular area, we need to add a mask or segment. So to add that, we are just clicking on add segment, where we are defining the range to capture the bone and to uh, specify that range. We have these presets here. If I wanted to capture bone, I will be able to get it. So generally, the bone Hounsfield unit or threshold value starts from 226 and it ends with 3071 in general scan. But in this scan, the maximum value is 2291. So that is why the maximum value we are able to see it 2291. So now if I click on apply, I will be able to see the this pixel covered between 226 to 2291. And if I wanted to cross verify, if I hover on this particular pixel onto the right hand bottom corner, you will see that whatever the pixel that we have selected in the 243 images, it is in the range between 226 to 307. So this is the first step where we are differentiating the 2D information data. Like I wanted to capture this region as a bone. So that is a process called thresholding. So from here as well, you can change the threshold value. For now, I'm good with the threshold value that we have. But now this particular information, I'm able to see it in the 2D image. But in the real quick, if I wanted to see how my mask is appeared here, I need to click on 3D and just need to click on center fit. So by using the threshold operation or threshold 2, we have applied the threshold value between 226 to 307, 2291. So now I'm able to see the image information here in the 3D manner. It is not a 3D object yet. It is just a mask which we have the information in the 2D. For our demo purpose, I will stick with the right side of my knee here. So to get rid of all the other information, the second tool that we have, edit segment. Here, if we go deep into this particular tool, we have paint or erase. For now, what we need to do, we wanted to erase the other part that we have. So I'm clicking on erase and I'm clicking on lasso so that in freehand manner, I can select these regions. So I have selected brush shape as lasso. So you can see if I select this particular area, which I don't want into my 3D virtual model in the final output, I'm just selecting that and clicking on OK. So now by using this edit segment erase option, I'm able to see this particular right side is only appear and the other rest of the left side part we have removed whatever the threshold that we have applied. Now in the parent mask we have this right side of me. So if we wanted to split this apart, all these three femur part, patella part, tibia, fibula, then we need to split into a three different regions. So for that, what we need to use, we need to use from the segmentation toolbar, we need to use the split segment. So now here, the parent mask we have selected, which is the green one, segment one, but we wanted to divide it into the three different parts. But here I can see only two. So if you wanted to split it into the three different parts, I wanted to click on the third plus button so that I can create one more. So now here I have created these three different segments or masks what I will do, I will represent segment 2 as my femur part and segment 3 as a patella. These are the seed points that I'm giving the information to the algorithm that segment 2 I'm considering it as a femur part, segment 3 I'm considering it as a patella, and segment 4 I'm considering it as a tibia fibula. So now seed points has been given to the algorithm. So if I click on initialize, automatically the algorithm will get to know about these three different parts that I want to split it apart. Now you can see I'm able to see these three part from the parent segment. I've split it apart. Once I'm good with my result, I'm clicking on apply. So this was the earlier mask that I was having. I have splitted that into a three different parts: femur, patella, and tibia fibula. So if I wanted to rename it as a femur, I can do that by a double click. Femur, patella, and tibia. So now I'm having these three different parts together, splitted. I will go one by one. So here you can see I'm having this femur part, but can you see there is a floating object appeared here? I wanted to get rid of that particular floating object. So we have this tool called island. What it will do, it will own, when I'm clicking on the femur, whatever the floating part which is not connected to the femur, it will not consider. So when I'm selecting this island, clicking on the femur part, it will create a new mask and it will get rid of the floating object. Now I'm having this femur part with me, which is having couple of holes here, and it is hollow from the inside. If you wanted to go slice by slice approach, then what we can do, we can again go back to the edit segment. Now we wanted to cover that region or paint that region. So I will just go from the beginning here and I will try to cover that part in the 2D image. Also, I will able to get the information into the 3D virtual model. So now one slice has been covered, but there are 243 images. For that, we need to cover this region. So to do it quickly, how we can do it? We have the other tool called multiple slice, where we are giving the information to the algorithm in one slice here. I'm just zooming in the other views as well. So I'm considering this one slice, skipping one or two slices, again doing the painting, skipping one or two slices, again doing the painting, skipping one or two slices, again doing the painting. Now if I click on initialize button, can you see? I have applied only couple of slices, but when I click on initialize, automatically in between region is filled. And how I can check that in the preview? You can see these four slices we have filled in the slice by slice approach by skipping one or two slices in between. But then too, it is identifying in between region that I wanted to fill. So that is called as interpolation. So it automatically fills in between gap. So if I click on apply, automatically in between gap will be filled. So this is the multiple slice. operation or the tool that we have. And if I wanted to also fill these slices, I can again do that by using this paint operation. And if I click initialize and apply, this gap will be. So this is the general method, but sometimes depending on the threshold value, if you wanted to fill the region. So we have the intensity, threshold intensity. So you can define on your depending on your purpose, you can define this threshold value. So for suppose if I wanted to only uh, get the bone value here till the last. If I want to cover, then I'm just reducing this along with some bone. I just wanted to cover this cancellous bone. So there are two parts in the bone, which are the cortical bone and the cancellous bone. Cortical bone means the dense bone that you can see here in the brighter region format. This called as a cortical bone, which is on the surface, and the inside part you can see is a cancellous bone, which we generally call as a spongy bone. So if you wanted to capture the inside bone as well, what you can do, go here, edit segment, click on threshold intensity, and depending on your use case, if you wanted to capture from 150 to 2291, you can just select those regions, and automatically the if I zoom in and check the right side region here, and if I want to capture this 171 pixel, and here I have already provided my range. If I click here, automatically the range between 150 to 2291 will be selected. If I hover this, you can see the information here as well, the output unit 208, 217, 171, 221, 167, and 170. So within the range, the value has been selected. So likewise, we can go slice by slice approach. And in the multiple slice as well, we have provided that option to enable threshold intensity to capture a particular region. Just showing you slice by slice approach, skipping a couple of slices. Can you see the difference? Whatever the range that we have applied is between 150 to 229. And if I click on apply, initialize and apply, these pixels will also be selected. So these are the two tools that we have seen: edit segment, multiple slice, and also we have seen the split segment. This tool that we have seen to get rid of the disconnected part, like here that we were having this part, floating part, and we use the island to get rid of it. So these four tools we have seen till yet. Now, if I wanted to fill this inside region or the outside surface, how I can do? We can go to the smoothing, this close fill hole operation, and I'm increasing the kernel size so that, and I'm clicking on edit 3D sphere brush. So it will allow me, when I'm ticking on these two options, it will allow me to work on directly 3D. So now, if I zoom in here, if I apply close fill holes operation here, can you see that holes, whatever the brush I'm applying on the surface, these holes are closing. So this is the operation called close fill holes.
I'm doing, and closing the holes from the outside surface in the 3D real quick manner, and we can see that this being captured. Now this is about the femur part that we have covered, but if you wanted to fill from inside, you can do it by using the wrap solidify option and coverage. I'm just choosing fine and clicking on apply option. Now background algorithm will work. What it will do, it will try to check the outside boundary, and whatever the inside portion is hollow, that it will try to fill. And you can see once I have applied, inside portion of the femur is being covered properly and it is filled. So this is the operation for capsule repair which helps us to fill the inside region, or else if I go with the largest cavity, means if you wanted to have this inside bone cavity or largest cavity as a separate mask, if I click on this largest cavity and if I click on apply, I will be able to have this cancellous bone directly. So sometimes there is a request from the surgeon that I want this bone, the cortical bone separate and the cancellous bone separate. That time this tool will be helpful. So now I'm having this solid femur with me. Now what we will do, we will also do the same operation for patella and uh, the tibia as well. So we will do it quickly for the patella. Same thing we will do. We will try to capture this region and we will try to get rid of the floating objects by using the island. Now I'm having this patella with an, and now from this side, the portion is already open. What I will do, I will try to capture this region and I'm using the add operation and using the circle. I'm going slice by slice approach and I will untick this threshold intensity as I wanted to fill this part, and I'm able to see that the boundary of my patella is still here. I'm just covering this part, skipping one or two slices, covering this part and creating a solid model, zooming in by using control and middle mouse button, zooming in by clicking on these particular pixels that I wanted to cover. As this is the part of patella, so I need to cover this particular pixels. So now uh, I need to also cover this part, covering this part, and clicking on initialize, apply, and have a couple of regions here, and initialize patella, and do that again, and try to fill because the other part was not filled, not selected. Control Z if you wanted to go back to the earlier step. Now you can see earlier it was hollow, now it is filled, uh, but there are a couple of regions are still there open. So what I will do, I will use wrap solidify surface holes and I will give you the minimum value as the size of patella is less. So automatically this inside portion will be filled. And now I can see there is one sharp edge is appeared here. I can get rid of it by using smoothing operation and using Gaussian and applying brush directly onto the surface. Now this particular sharp edge is vanished, and from the 2D image also we will be able to see this patella is properly covered. Now we will move to the third part, which is tibia fibula, and I will hide this. We will need to do the same thing. Uh, to get a particular model filled. So what I will do, I will just split this tibia from the fibula. For that, what I will do, I will go to edit segment, use erase operation and go lasso, and I will untick this and I will try to chop this region and I will get rid of to the fibula. And now can you see this part is not connected to the tibia? So if I wanted to get rid of it, I will use island tool and I will click on uh, this particular region. Now I'm having the tibia separate. This portion is open. I wanted to close it. There are 2 to 3 methods to fill that hole. As we have seen, simple one slice edit or multiple slice edit. So I will preferably go with the multiple slice edit. Why? Because it will reduce the overall time as we are giving input in couple of slices and in between gap is filled automatically by using the interpolation operation. So we'll try to capture it is in the 2D axial view. Skipping 1 or 2 slices. Skipping 1 or 2 slices and covering this region. Going to the other part of the bone in the axial view. You can see the progress in the other view as well. Here you can see we have selected 3 slices and a gap between the slices. As we are using the multiple slice, it will not need every single slice to be segmented or to be covered. So that is why we are using this multiple slice, which will work on the interpolate operation and automatically will fill the gap. Skipping 1 or 2 slices, going back to the boundary of my tibia and now covering this part. You can play with zoom in, zoom out whenever you are you wanted to reach to a specific area of the 2D image. Now you can see this is covered. I'm going to the other below slices and trying to cover this region. And here I'm just covering this part using the left click of my mouse to select that area. And here also skipping a couple of slices in between and zooming in by using control and middle mouse button. Now automatic save is happening. Now I'm just doing the multiple slice, selecting a couple of slices more and I will try to capture this region again. And roughly I have captured this particular part which is open. Now what I will do, I will use this add operation and clicking on initialize. Now I'm able to see the in between gap is filled automatically. Clicking on apply, I'm satisfied with my result. Now what I will do, but still there are particular gaps are there. What I will do, I will try to capture the last slice of my tibia so that from outside, if we cover properly, then we can apply the wrap solidifier, which will help us to automatically fill the inside region. Now, from the outside, you can see in the 3D as well, we have captured the region. So now from the outside, most of the region is captured, but here you can see there are a couple of holes. We can get rid of it by using smoothing operation and here close to the loads. We will try to capture this region. You can see I have applied this and the gaps or the holes are filled. So by these couple of tool uses, we can get rid of the holes. And here we can see there is a sharp edge. Before that, we have a couple of open pixels as well. I wanted to get rid of the sharp edge which is appeared here. I'll just change this value because I wanted to use on the small region. So I'm just decreasing my kernel size. Click on here. You can see. Now from the outer region, my tibia is filled and I will use finally the wrap solidify by and clicking on apply and this gap will be filled automatically. Now I'm having the next mask which is solid. If we wanted to change the color, we can change that color. Here you can see. So now I'm having all three parts of the right knee, which is filled one here, this femur, tibia, and the patella. This one, which is the solid one. These three bones we have segmented and we have captured it properly by using the edit segment, island tool, the multiple slice tool, split mask or split segment. So by using these tools, we have converted this 2D image information into a 3D virtual model. But now this information is it in 2D form. If I wanted to convert into a 3D virtual model, we need to use this option by selecting this femur solid. I need to click on convert segment to a model. I'm using none. So once I click on this, automatically from segment, it will shift to 3D objects. Now, if I hide this mask as well, I will be able to see the 3D object here. And here you can see the contour or the outer shell. And I'm just changing my brightness contrast by using the right click. I'm just pressing continuously and changing from left to right or top to bottom. So from here you can change the brightness so that the image will be much more proper as per your vision. So we did the conversion for the femur part. We can convert, we will do the same procedure for the patella as well. I'm just checking this, converting it from mask to object. for the patella, and for tibia also we will try to convert it to object. Now I can hide this mask as this is the 2D representation. For now I will not need it as we have converted this into a 3D virtual model and we are able to see it here. But from here we can export these all three model one by one to a desktop now, and if I click on save, STL will be saved. STL is the 3D representation of this bone. I did it for femur. I will same do the procedure for patella, saving it on desktop. For tibia, you can save wherever you want. Click on this, click on save. Now, even though if I don't have the software, if I go with this particular path, yeah, okay, and having femur solid, which is on desktop. If I click on this, here you can see the 3D virtual model is ready. So whatever the virtual model we have created from my segmenter, the segmentation software, we can export it to the design software wherever we want as a STL model. So likewise, we can do it for patella, tibia as well. And we can save this file in the .my. So I will just rename it as me and saving this file. So this is the process of segmentation. And also, if you wanted to measure something, like you need to click on measurement. I'm just hiding the other part so that if you wanted to see from the top to bottom distance, you can also do that. I'm clicking on measurement. And you can check into the 2D as well, this information, and in the 3D as well. If I zoom in, if I click on here, you can check here and you can edit it from this location, the 2D image as well, or from the 3D as well. And this is the measurement that we have, which is nearly about 130 centimeter. You can also measure the angles as well. That is one of them. So likewise, you can do the measurement and you can also do the annotation. For example, if I wanted to name this as femur, I can name it as femur. And you will be able to see the information here. And you can also drag or drop wherever you want. So likewise, we can do the segmentation measurement and whatever the STL that we have gathered, we can print it by using the 3D printer in the physical manner. So this is all about the knee segmentation. And now the floor is open for the question. So you can drop the questions here. Is this is open source software? No, this is the FDA cleared software that we have, and you can get this from this particular link, mysegmenter.com. You just need to click on login or sign up. You need to fill the details, and once you have your account, you just need to log in and you will get the exe file to download. Any other questions related to the segmentation? I'm just dropping the link for the software in the chat. Any other questions? If we need to practice, where can we get the data? Another question that we have. So if you wanted to want the data, what you can do, you can again go back to this particular website. Here we have kept the sample data. And if you download this data, you will be getting this .mys file. I'm just showing you one sample here for shoulder. If you download this, you will get the data. If I double click on the shoulder, I will get the DICOM data directly imported into the software. So that file you will be able to get. Whenever it will open, I will show that. Let's move on to the other question. Yes. The other question is, so in this segmentation, we just segmentation bone only without PCL, ACL ligament. Yeah, we were focusing only on bone, but if you wanted to go with the soft tissue segmentation, that also we can do. It is dependent on the threshold value that you are selecting. We selected for the bony region from 226 to 3071. But if you are going with the ACL, PSL or soft tissue segmentation, the Hounsfield value will be less than 226. So it will be in the range between 0 to 225. But depending on your scan quality, whatever the pixel that you wanted to select for that particular ligament, you will see by using this particular information. For example, if I'm just deleting this. For example, these are the soft tissue that we have for shoulder. And if you try to capture this, you just need to hover on this particular pixel where you will be able to get the information here, which is far more less if you compare to the bone value. So depending on this particular values of these particular pixels, which are appeared here, you can choose the value of the threshold. If I check and if I try to check for the soft tissue, taking more less than the 225 value here, can you see here? These soft tissue are being covered. If you click on apply, you will see that. And depending on you use, whatever the region that you will be able to you want as a soft tissue part, you can capture. And uh, once you click on apply, there will be multiple pixel will also be appeared in the segmentation. You can get rid of those particular pixel by using edit mask and split by using erase operation. How much the price of software? So you can get this information on the website itself. Once you log in, you will be able to get here. So I will show both the details, how you can download. Once you have the account, you can download the My Segment from here, and you can see the price, monthly subscription and yearly. This is the price. And for the beginning itself, we have provided this software 1 month free trial. So whenever you are logging in, you will be entitled to get 1 month trial license automatically. We will not ask you any information. Just what you need to do, you need to go to the mysegmentor.com, click on sign up page, fill the information, and click on logging again, and you will be able to get that downloaded website. And 30 days trial license you will get. Okay, I guess these are the questions that was there. And in the next episode, we will be focusing on OMF and CMF anatomy. So we will discuss much more further on the OMF CMF anatomy in the next episode. And if you have any question for regarding the segmentation, we can cover up in the next third episode as well. Or if you have any question right away, if you wanted to ask, you can directly uh, mail us on this contact@3dsurgical.com for any particular question.